Hello and welcome to the calculator guide video on finding a regression model for an exponential relationship on a Casio Classwiz fx-991EX. We're going to be having a look at this question in this video. It is from the Edexcel A-Level Mathematics, Statistics and Mechanics Year 2, which is by Pearson Education Limited. For your reference, it's exercise 1B, question 4 on page 7, and there's a link below in the description for you to buy yourself that book if you don't already have it. Let's take a look at the question. The number of atoms of a radioactive substance, N, is measured at times t minutes after the start of an experiment. And we have the table below which shows the data. We've got time t, and we've got atoms n, and we've got space to fill in the log of n. This is because we're going to code this particular data, and it's given us some information about the code here. The data is coded using x equals t and y equals log n. Okay, so for part A, we've got to complete this table, and we are going to use spreadsheet on the Classwiz to help us out with this one. So it's menu and 8 for spreadsheet. Now, we don't have to worry about inputting time into this one. It's just the atom row that we need to code using the logarithm of these particular values. So let's start inputting the atoms. Remember, it is better to work in columns in spreadsheet, as once you've pressed equals, the line automatically scrolls down to the next row on there, so much easier to work in columns than rows. And once we've inputted the last bit of data 2, then we want to scroll back up to the top and cell B1. Now we're going to use a formula to help us code the data, so it's option and 1 for fill formula, and then navigate right so we can enter our formula. Now this is going to be log to base 10 that we are going to be using, so it's shift and then the negative number button, which gives us a log here. You can use log to any base if you like, but it's best to use a base of 10 because we're going to be making use of that when it comes to part D. And rather than input n in here, what we're going to do is input the location of the cell which contains the data we want to convert. So for the cell that's in B1, we want to use the value that's in A1. So we want alpha and A and 1 and close the brackets and equals. Range is going to be the range of cells that we're going to apply this formula to. Because we've got 5 bits of data, then we want to change the range, navigate right, keep the first cell as B1, and then the second cell we want to change to B5, press equals. The calculator will automatically use the corresponding values in the adjacent A cell, so B2 will use A2, B3 will use A3, and so on. So that will automatically happen. So all you need to do is press equals to confirm. And you can see here that we have our coded data. These have all been coded with the logarithm of the value in A. And all we need to do is to simply copy these values down into the table and fill it in. So once we've done that, onto part B, we've got to calculate the product moment correlation coefficient of the coded data. Now we're going to be transferring to statistics to do this. So it's up to you what you do now. You can store each of these individual results into the calculator's memory if you wish. There's 5 different results, so there are enough memory spaces for you to be able to record them if you want to maintain the accuracy. And we'll be having a look at that a little bit later. If not, provided you've recorded the values in your table, we can use those in statistics mode going forward. And that's what I'm going to do. So let's press menu and 6 for statistics. Now, because we've coded the data, the relationship between t and log n, i.e. the relationship between x and y, is going to be a linear relationship. And so we need option 2 here, y equals a plus bx. You can see that follows the pattern of the equation of a line of regression. So it's 2. Should have columns here for x and y. Maybe you've got the frequency column active here. If you have, then just leave it as the default of 1, which should automatically come up when you enter the values. Alternatively, you can switch it off like I have. But don't worry about it too much if it's there, just ignore the frequency column and start entering your x values, which is your values for t, into the first column. And as with spreadsheet, it's much easier to work in columns here. Once you've entered your last value, you just need to press down and then right, and that's the quickest way to take you back up to the top. Now y, remember, is our log values that we want to input, so they are the values that we found from part A. So just start inputting that. Remember, if you have stored them, you can recall them at this point if you've stored them in the Classwiz memory instead. So let's just take a moment to do that accurately. Okay, once we are done, then we need to press option. And then we want to choose 4 for regression calc. And what we're interested in the first instance here is this R value, which is the product moment correlation coefficient. We can see we've got minus 0.9795 to 4 decimal places. And so we can record that as our answer to part B. In the answers in the back of the book, they have said minus 0.980 to 3 significant figures. In fact, all of the results are given to 3 significant figures. Before we move on to part C, let's just take a look at the A and B result that we have here. These are essentially the intercept and the gradient of the equation of the regression line that we have. And you can see they are very, very similar to the equation of the regression line that we're actually given just above part D here. You can see there's a slight rounding difference in part A. We've got 2.486, they've got 2.487. Maybe if you used stored and recalled values, maybe you've got to 2.487 there, slightly more accurate answer, but it's very close. And we can see the B there, the gradient of the equation of the regression line, minus 0.320 to 3 significant figures. That's the same as what they have here. And so that's good, that matches what we're given, so we know that we're on the right lines here. Okay, so for part C, with reference to your answer to B, state whether an exponential model is a good fit for these data. Well, let's just have a think about what we've done. We've coded the data from its original relationship, and that's produced a linear relationship between X and Y. And if we have a look at the correlation coefficient, we've got minus 0.98, and that represents a very strong negative correlation. So the two are very strongly negatively correlated. And if we have a result that is very, very close to -1, or indeed if we have a positive result that's very close to 1, then that would mean that the exponential model is a very good fit, because when we code the data and look at the linear relationship, it's very close to 1 or -1. So yes, we can say the exponential model is a good fit because we've got some very strong negative correlation very close to -1 there. Okay, so for part D, we are given the equation of the regression line here. Now what I'm going to do, I'm going to use those stored figures that we have here, A and B, simply for convenience. You can use a direct read off of the values that we're given here from the regression line from part of the question if you prefer, and certainly if you've used more accurate data you've probably got those anyway. And I've checked previously with the answers and we still get an accurate enough answer when we work these out, so you're fine to use the results that we have here. We need to go to the statistics calculation screen, so it's option twice here, then scroll down to one statistics calc, and in this area we can use any of the statistics that we had from the data which we entered. We can use in any calculation, and it does operate in line mode automatically here. Now what we're thinking about doing is we want to change this into an expression for n in terms of t, and if we have a look at the form of the expression that we have there, n equals ABT, that is an exponential relationship. Because we now know that the exponential model is good, a good fit for the relationship between the time and the atoms, what we're going to have to do is uncode the A and B values that we found for the equation of the regression line, all the ones that are given here, so that we can get the A and B part of this exponential relationship. To decode, if you like, what we're going to do is going to do the inverse of log to base 10 to the A and B values. Well, the inverse of that is 10 to the power of those respective values. So we want to have the A and B values that are stored as our exponent with a base of 10. So it's 10 and then the power button. You can see here it's operating in line mode. And then we can actually recall those A and B values. It's option, and then you must navigate down one, and it's for regression here. So not regression calc, but for regression. And then one to use value A, close brackets and press equals. And here we have our value A, which is going to be used in our exponential expression, 306.5. If you're using more accurate results, or perhaps the 2.487, I believe you get closer to 306.8 in this one. I've checked in the answers, they say anything that's 307 to 3 significant figures, or that would round to that, is acceptable as an answer. So we can say that's 307 for our value of A as part of the exponential expression. Let's decode B then. So we want to do the inverse of log to base 10. So once again, it's 10 to the power of, and then we want to option down to for regression, and then we want to choose B. And again, you can just input the values from the regression line given if you prefer. press equals, and here we have a result. And once again, the answers are to three significant figures, 0.479 to three significant figures. And so we're happy that that's B. Now there is a second way to find these values, and it's a great way of being able to check that we've converted this correctly. What we need to do is we need to change the relationship that's put in the calculator between X and Y. So if we press Option and 1 for select type, remember initially we chose 2 for the linear relationship. That was the relationship between X and Y, so between T and the coded data log n. If we scroll down, let's just take a look at option 2 here. You can see that is very, very similar to the way that the equation for the expression for part D is written. Our n is y equals a times b to the power of, and our x is t. So if we select 2 from this second page here, then we're going to be looking at an exponential relationship. Now we've got our x and y values from when we inputted them before. The x values are absolutely okay to stay the same, but we need to change the y values to the uncoded version. So what we were given originally, actually, the values for atoms. So let's input those now. So it's 231, 41, 17, and so on. Okay, so once we've got the original data inputted in there, it's once again Option and 4 for Regression Calc. And you can see here we've got our A and B values. Let's just check them. We've got 306.8. Remember, that's the slightly more accurate result, but it's still 307 to three significant figures. And then B, we've got 0.479 to three significant figures. So they're the same results that we got when we did our conversion using 10 to the power of. And you notice here that we've still got the product moment correlation coefficient as minus 0.98. 0 to three significant figures. So that's still confirming we've got the same relationship between the two pieces of data there. So there we go. A slightly lengthy question, but a very good question to explore using the Casio Classwiz. There is a link below to get yourself a copy of the book if you haven't already. And incidentally, I'll just mention, if you are checking with the solution bank answers, the work solutions to this particular question, there is actually an error for part D, but they are correct in the back of the book, so I would just use those to check any of your answers. Also, don't forget to subscribe for future videos, but that's it for this video. Thank you very much for watching, and I will see you next time on the Calculator Guide.